Hey guys, today we're going to be taking concentration one step further, and we're going to be looking specifically at ionic compounds in water and what are the concentration of each individual ion in an ionic compound when it's dissolved in water. Previously we've talked about solubility rules. Ionic compounds, remember, will dissociate if they are soluble in water. That means that the forces of attraction of the water molecules to the ions themselves will overcome the forces of attraction between the ions in their crystal lattice. What that means is that each ion is going to separate in solution into its positive and or negative form. For example, sodium chloride. Sodium chloride is fully soluble, and when put in water, it will dissociate into Na+, sodium ions, and Cl- chloride ions. So when ionic compounds dissolve in water, the relative amounts or concentrations of ions is going to be dependent upon, number one, what was the original amount of the solute put into the water, and two, how many ions are there in each mole of the compound. So going back to my sodium chloride example, when 1 mole of sodium chloride dissociates, that means we end up with 1 mole of sodium ions and 1 mole of chloride ions. So in other words, we end up with 2 moles of ions total in this solution. And that's really important to keep in mind. But as we learned back in Unit 1, not all ionic compounds are going to have 1-to-1 ratios in their crystal lattice. If the charge of an ion is not the same as its counterpart, so for instance, the cation and the anion have different charges, the ratio is not going to be 1-to-1. So for example, in calcium chloride, it's CaCl2. There are twice as many chloride ions as there are calcium ions. So let's say that we had a concentration of 2 molar aluminum nitrate. If it was 2 molar aluminum nitrate, that means that the concentration of aluminum ions in the solution is going to be 2 molar. But because of the fact that you have 3 moles of nitrate for every 1 mole of aluminum, the actual concentration of nitrite ions is going to be triple the concentration of that aluminum ion. And so what you're going to see is a concentration of 6 molar for the nitrite ions. So let's take a look at a practice problem. Here I've got lithium fluoride dissociating in water. My question to you is, if I had 12.97 grams of lithium fluoride, I want to know what's the concentration of each ion in solution at the end of the dissociation. So the first step to completing this is to understand that we are in grams and we need to be in concentration. So that means we need to go from grams to moles initially. That means we divide by our molar mass, 25.94 grams per mole of lithium fluoride. This means that we have half a mole of lithium fluoride. Now we've dissolved this half mole into a half liter of water. So what we need to do is say moles divided by liters. So we have 0.5 over 0.5, which gives us 1. What that means is that we have each ion in solution at 1 molar because they're in a 1-to-1 ratio. So the concentration of lithium fluoride in solution is 1 molar, and the concentration of each ion in solution is also 1 molar. So in this practice problem, we have 3 moles of magnesium chloride being dissolved in 1.4 liters of water. This means that we dissociate 3 moles of magnesium chloride into 3 moles of magnesium ions and 6 moles of chloride ions. Each of them is going to be in 1.4 liters of water. So we take our 3 and divide it by 1.4, and we take our 6 and divide it by 1.4. Well, 3 divided by 1.4 is going to be 2.15 moles per liter, which means that our magnesium ion concentration is 2.15 molar. 6 divided by 1.4, that's 4.29 moles per liter, which means that our concentration of chloride ions in solution is 4.29 molar. So now I have a challenge problem for you. Here we have a situation where we're taking 23.5 grams of aluminum sulfate and we're dissolving that in 1 liter of solution. We also have 19.6 grams of calcium sulfate and dissolving that in 1 liter of solution. We are then combining the 2 solutions together. Your job is to find the concentration of every ion in solution once these 2 solutions are combined. Go ahead and pause the video, take a second to work through this, unpause it when you get an answer or if you get stuck, and we'll work through it together. Okay, so now I've had a couple of seconds to work through this. Let's work through it together. The first thing we need to realize is that we're starting with grams and we need to get to concentration. If we need to get to the concentration of every ion solution, the first thing we need to do is figure out how many moles of ions we have. So we're going to look for the number of moles of each ion in solution first. We've got 23.5 grams of aluminum sulfate, so we're going to convert that into moles and then figure out the number of moles of each ion once we do that. So first, we're going to take that, divide it by the molar mass, 342.14, to find the number of moles. This means we have 0.0687 moles of aluminum sulfate. Now, to find the number of moles of aluminum ions, that means we have to double this because there are 2 aluminum ions for every 1 formula unit of aluminum sulfate. For the sulfate, we have to triple it. So now what we're going to do is we're going to double it for aluminum, triple it for sulfate. So now that we've found the number of moles of aluminum and sulfate, we're going to now look at the calcium sulfate and figure out how many moles of aluminum sulfate from this. So we start with 19.6 grams, we divide it by its molar mass, and its molar mass is 136.14 grams per mole. This means we have 0.144 moles of calcium sulfate. Because they're each in a 1-to-1 ratio, that's actually going to be the number of moles of calcium and the number of moles of sulfate coming from this compound. Now, to go from this to molarity, we have to divide by volume. Now, I hope you caught the tricky part here. Our volume is originally 1 liter for each solution. But I asked about the final volume, which in this case is going to be 2 liters. So what we need to do is divide each number of moles of each ion by 2. The other trick here is that the sulfate actually came from 2 places. So that 0.144 moles of sulfate coming from calcium sulfate and the 0.206 moles of sulfate coming from aluminum sulfate actually have to be added together. So those are the 2 tricks to this problem that I hope you were able to catch. So again, let me repeat what I'm about to do. I'm about to take the number of moles of aluminum divided by the 2 liters of our total solution. I'm about to take the sulfate, combining the sulfate from this substance, the aluminum sulfate, and the sulfate coming from calcium sulfate, and then dividing that total number by 2 liters. And finally taking the number of moles of calcium that we have and dividing that by 2 liters. So that's going to be the next step. I'm going to do those all together right now. Okay, so now we've got a situation where we know the final concentration of aluminum ions in solution is 0.0687 moles per liter. The final concentration of sulfate ions in solution is 0.175 moles per liter, and the final concentration of calcium ions is 0.0720 moles per liter. We have 3 sig figs in every answer. We have the final concentrations. This one was tricky, but this is going to be one of the more common types of problems you're going to see as you go through this topic. All right, so that wraps up today's video. Today we learned how to find the molarity of each ion in a solution given the fact that we're dissociating ionic compounds. Remember, the final concentration of each ion is going to be dependent upon the mole ratio of ions within the compound and both how much of the compound was added and the volume to which it was added to. Also remember that volumes, if brought together, are always additive. So if you're adding 2 solutions together, you always have to add those volumes together. You don't have to add volume, however, if we're simply adding a solid to a liquid. I'd like to thank Adam Bertrand for writing, filming, and editing this video. I'd like to thank you guys for watching it, and I'll see you in the next one.